All right, welcome to ClueCon 2025. I think I get used to this after 21 times, but basically, I just wanted to talk about why are we even here in the first place. You know, we've been through this. This is 20 years of FreeSWITCH now, and when we started this thing, we were worried about how far away the control was from anyone being able to make anything with telecom, right? That was the spark. Was people were charging hundreds of thousands of dollars to just change their systems at all. You'd have to put in a change order. It was expensive, $1 million a year in support, equipment you weren't allowed to see. That's what the landscape looked like, and it just pissed us off a lot, right? We're like, why is this like this? We're already seeing evidence that you can do this with computers. Why are we having all this crazy stuff, right? So the first revolution that we started back then, led to, how hard can it be? Very. We started writing code, got big lots of deployments everywhere, learning the hard way from crashing, finding out all the different race conditions and stuff that comes. But the mission was to make software that could do the job of this particular hardware that everyone was holding hostage from everybody else, right? So because of that, we allowed some pretty big logos to flourish, saving some of them from certain doom. If it wasn't for us, Five9s wouldn't exist right now because they were spending tens of thousands of dollars per device on hardware stuff that they couldn't afford, and they had to replace it all with software. So we proved it, right? We proved that telephony can be software, and then it can be modular, and it doesn't have to be putting it in racks of very expensive equipment that's made just for telecom with special audio code boards and all this different stuff. So we did that, but the problem was it's not exactly easy. We were a little bit surprised, our team that was working on FreeSWITCH, because we were we've done it. It's super easy now. And then people look at it sideways. And we find that they would have to, we ended up the classic, your docs don't tell us what we need. And then we're like, oh, how are we going to fix that? So we'll try and make them better. We write books about it. We give people kind of lessons on how to work things, but not everybody kind of caught on. I think after a while, we got to hit some stride. But there's all these weird things that people have to struggle with. Even when they're using software in a telecom environment, because you have to know how to set up your network right to do voice over IP, and we tried the best that we could to make that stuff easy. At one point, we had a challenge for ourselves that we would this is before all the containers and everything, but we could just grab a make file off the internet in an empty directory, and it would build the entire FreeSWITCH and turn it on for you. Because we were just all these different obstacles are really hard to overcome, and we wanted to do something about the real problem. One of the big reasons that we even made this software is we were seeing people trying to build stuff as products and services and having a hard time making it work. And what happened is that we realized that we were seeing people hiding the pain and not solving it, right? So we have, it's easy on the outside. Don't worry about the inside. But on the inside, this is a chart of what a typical VXML deployment would be. And everyone was just happy with that. Okay, fine. The more boxes in a flow chart, the cooler it is, right? And you put these things in place, but you had to buy every one of those boxes, right? And you had to have a subscription. So it was still kind of a really difficult pattern. And today we're seeing every one of the voice XML people are refugees from it. Verizon and Microsoft and everybody that thought it was so cool. They really got rid of it. Never really worked. But we had this voice XML, which was inspiration for us all, because the idea is good. Pretty cool, right? You can take a document and explain what you want to happen on a phone call and just worry about the document, right? So that one idea was good. The way they tried to solve it was the most over-engineered abomination ever known to mankind, right? Trying to take XML and turn it into JavaScript just in time and run it and hope the environment was right and all these different things. Then all of a sudden it got so hard you needed special hardware and you had to pay for the editor to even create the voice XML. So it kind of went sideways. So we were worrying about this problem too. We started making features in FreeSWITCH that were dynamic configuration, because we thought we have this software media engine and it allows you to bring this stuff in here to FreeSWITCH, but we don't want you to have to only configure it. How can we dynamically configure it? We made a little thing called XML curl that's like, was supposed to be a demonstration of how you can put configs into FreeSWITCH any way you want. But the thing ends up being the #1 used module ever of all time, because everybody learns what it is and goes, holy crap, I can just hook a web server up and like deliver my configs to it anytime I want. This was the reason we have a CPaaS industry right now. That module inspired most of the CPaaSs that you see, because they took that and tried to make their own spin on how to configure those kind of things, right? So we were in that. We weren't worrying about the big problem of the end users yet at this point, because we were working on the academics of making sure that we had a system that was flawless and could scale to any size. But we inspired the first generation of CPaaS, and that brought you Twilio, who of course you know, and they did their TWIML, which is a similar concept, also trying to solve XML, voice XML their own way. It just doesn't age well, right? We tried to support it ourselves. Our engineering team was really mad when we asked them to be able to support TWIML because they didn't like how it worked. We actually had to tell them to simulate all the reasons that it worked poorly, because we wanted the experience to be the same, so they weren't thrilled about that stage of our growth. But otherwise, with these different things, you're just stitching together a bunch of different stuff, hoping that you're going to get something that works well. And the problem with that is, usually there's like a punishment for that. Like if you're trying to build something that uses one piece over here and one over here, and you're going through a network and you're trying to make it all fit, you end up with race conditions and latency and a bunch of other horrible things that are really hard to overcome. And you won't find that out until you put it in production. And then people will start to talk to whatever you made on the phone, or experience the, hold on a minute, and then it's dead air while you're waiting for a transfer, and going to looping so many times through the PSTN that you can't even hear the person. And your customers are all beating their head against the wall, because then the agent's like, I can't hear you, can you speak up? You're yelling in the phone, all those fun things. And we've been trying to figure out how can we solve this at scale the entire time. When we built FreeSWITCH in the first place, that was why we built it. Because the step one, how can we make it all be software? And step two was, how do we get it to work on like virtual compute? Because that's just started to happen around the same time that we were building this, right? There was just the earliest versions. You still had to like have a special kernel and stuff. But we were seeing virtual machines. But it's like a real-time application that depends on perfect clock, having to run in a virtual computer that might even get migrated to a different computer while it's running. It made new challenges, because it was hard enough to find some kind of piece of hardware in the machine in the first place that we could rely on to figure out the timing. We had to come up with ways to do it, and survive all those different things. So we worked on that for years. As everything got more and more accessible, we left, we went into this like cloud world and were able to make our software run there. But what was really going on the entire time was the brewing of this perfect storm, because the internet was always a critical thing for us, because it's almost like the internet is necessary for communications, right? It used to not be, but by now it is. We're talking even like 10 years ago, right? And what really changed drastically is you used to have the internet, but only in your workplace. Like my server farm has a lot of internet, and I can put traffic on it and stuff. But my house doesn't really. It's kind of basic. I can barely browse the web browser. Like now we have gigabits in our phone, right? So like, what's missing is being able to have an internet that reaches every device everywhere with enough bandwidth to have communications. That being like any kind of embedded audio and video that you want to put into like a mobile app or phone call. Because you don't really want to go through the regular phone PSTN if you can help it, for 100 reasons. Cost, the reliability, the being at the mercy of someone deciding they don't like your traffic anymore. So like the more things that you can do through the internet, the more it pushes towards the real vision that we don't need the PSTN anymore. So we have this internet speed. We have cloud compute, which means we can put the computer anywhere we want. And we rely on clouds that already exist, but it's not even that big of a deal to put your own up nowadays. But for cost prohibitive reasons, you can just go grab something, especially when you're starting out, and have a computer and put it in place just long enough to run a test or whatever. All these advancements, if you can run your communications infrastructure that same way, that opens a lot of doors for you, right? And now we have this world where we've gone through a big dev cycle. When we started doing this work, there was a giant push to make contact centers and all these kind of things that were built through the internet, so that you would have like the agents are able to go to a website and they have call dispositions and all that stuff. And they settled on something, and then you got all these big logos like Amazon and Five9s and everybody getting into the contact center business. There is another dev cycle right now. I'm pretty sure everybody already knows it or you wouldn't be here. But there's the AI infusing with those same ideas is causing us to need something different, because you can't just say AI in the corner next to the thing you already built. That's what some of the enterprise companies started doing early, but they're frantically trying to build something else, right? And one of the things, if you don't have something modern, you're not going to be able to, because you need to be able to figure out ways to weave the two ideas together. Now, we've been talking about this for a while. I've come up here, I think, at least 2 or 3 times in the last couple of years, talking about some of the stuff that I'm trying to build with the team here. And you probably heard us talking about programmable unified communications. This is something that it took a while to figure out what we wanted to call this, because what we're really doing, and we're starting to see other people catch up, because I'm seeing little quips here and there, like, I wish that I could build the stuff that I see in a UCaaS environment without having to pay them for it. I don't want to go and get an account on a UCaaS provider just to have a soft phone that I can connect to my call center. I wish that I could just build my own stuff, but you always have to buy it as apps, right? So we have that, and we have the CPaaS world where you can build stuff, but it's you have 4 choices what you can do. You can send a text message, and you can get an audio call on an 8 kilohertz horrible PSTN line. And if you're lucky, you can bridge that to some kind of early stage IVR that, from the dawn of time, right? So we want to make unified communications programmable, which is why we call it. It's a pretty obvious name. It kind of rhymes with other category names, but it was really important that we do this, because we're trying to get across the fact that you can build the entire experience as a developer. We want you to be able to create anything that you want to build and not have to spend multiple years starting from scratch, because you will find that you will always run out of time trying to build that, because I am still building FreeSWITCH, and I have been here for 21 years, right? Okay? So we're trying to stop everyone else from being burdened by that kind of pain. So I look at it sort of like, someone killed there it goes. HTTP for communications, telecom, it's one of the other ways of putting it. The idea is that the web has always been cool since the minute it showed up. We were like, look at this, it's the web, I can build pages. It advanced from words to suddenly pictures, and then all of a sudden video, and then I can do all this cool dynamic stuff, and we came up with programmable DOM, and we have CSS, and it just flourished, right? You can build all this really cool stuff. And then the communications was always on the side. So you'd look at the web browser and you'd talk on the telephone that you had on your desk. And we really wanted those to be the same thing. So you have now a lot of work. The entire tech industry has been trying to work on this problem, so it's not just us. But WebRTC has been a giant collaboration among every browser implementer. It's a very good low-level tool for being able to embed a communication stream in a browser. But most of the time, the other side is meant to be left up to the inventor. And a lot of times, they don't really give you anything. So you have a WebRTC connection, and you can connect it to something, and here's some sound playing, but it's like either a peer-to-peer connection, or maybe if you get an SFU or something, you can have some kind of video conference. But there's no telecom network on the other side of that WebRTC, and that's what also pissed us off, so we started working on it. We want to be able to combine all the cool things between both of those worlds so that you could embed a conversation or a way to call your office right in your web browser and have it lead through a telecom pipe, not just like a siloed app, but the same logic that happens if someone calls you on your regular 800 number. So you write the application, you scale it globally, and then you can get to it from a web browser for richer content, but you can also just call it the old school way. So the way we're really trying to build things are, we have a markup language and the processing environment. So we have Relay, and Relay is the name for our core environment at SignalWire that we built that allows you to control calls live. This is like an evolution of all the work we've done. It gives you a WebSocket that you can run, say like Node or something, and you can control the call live. So we found that that was very useful when you wanted to build applications that say like went and fetched audio from a completely different place and then told us to play it through a command. So you could run this WebSocket thing and just follow along on the call. But then we also made a static version of this that lets you just declare exactly how you want the call to go. And this is where that same idea is still being applied back from when VoiceXML screwed it up, right? So we have a declarative interface to allow you to say the entire call flow and send it to us and let us execute it at scale, right? So you're working on getting calls from any medium and being able to run something on them. So it doesn't matter how you call. We eat them all in. You know, like we're agnostic to every kind of way that you can make a phone call, and we translate it to these core objects. This model is very, very, very similar to how the internet works in general. How does your web browser work? You type in a URL, you go to it, and it gives you content. So the R in URL is resource. We called our thing resource too. So we have these resources that are like the primary building blocks of every kind of application. Right, you have these scripts that are similar to HTML pages, and you have rooms, which are special use case when you want to put someone in a multi-conference. And obviously, queues allows you to put people in line for calls. Although that will probably become obsolete because now we don't need to do that anymore, because we have such cool stuff. We can call you when it's your turn, or you're waiting on a web browser for your turn instead of having to sit on the phone listening to hold music being crushed by G729 or whatever. So you can also plug in all of your existing stuff, right? So you want to connect it, you have a cool on-prem FreeSWITCH solution that you already built out, or Asterisk or anything, or any combo that speaks SIP, you can trunk it up to us or have calls flow through us any direction, right? So you can do it coming in, like you can put a SIP trunk and answer all your calls on your own system until you want to get to some of the stuff we have. You can put us as a front end in case everything goes down, there's still something answering. You can build an application that you can put in the web right away. And what I wanted to show off here was a little bit of an example of this. It's a very quick example that illustrates really the ideas that we have put forward. So we have, this is a simple concept, but it's actually a lot going on here. So we have this thing called the Tech Tarot deck. I think we still have a couple of them in the back if anybody wants one. But we built a tarot deck out of AI and just made it all tech themed, but it has similar stuff, right? So they took that, made this into a little website. And if you haven't, David was talking about meeting Sigmund, who's in the other room. He kind of helps us out along the way in other applications. So in this version, essentially what you'll see here is the AI is part of this web page. So if I want to call it, it will come into the web page. I can have a conversation with it, and it can manipulate the very website that it's running on. So it's actually able to cause the web page to change based on decisions that it makes through the conversation you're having with it. In this case, he's going to become a tarot reader. So I'm going to call him here.
I can feel your aura, Seeker. Let me take it in. Greetings, Seeker. I am Sigmund, the mystic SignalWire fortune teller bot, here to guide you through a mystical tarot reading. Your confidence really shines through, adding a wonderful touch to your overall appearance. Now I invite you to imagine shuffling and cutting the cards. Take your time and let me know when you are ready for your reading.
Okay, I'm ready.
As I draw the cards, I feel the energy of the universe aligning with your journey. Let us explore the wisdom these cards hold for you. In the past position, we have the Queen of Cloud Developers, reversed. This card suggests a time when you may have faced unsupportive influences or a lack of expertise in your endeavors. Just as in the world of technology, where a strong cloud infrastructure is essential for success, you may have felt adrift without the guidance you needed. This could have led to challenges in your projects, much like navigating through fragmented communication systems without a unified approach. Moving to the present, we encounter the Compiler Oracle, also reversed. This card indicates confusion and misunderstanding, akin to unexpected errors or bugs in your current situation. It serves as a reminder to thoroughly review and understand circumstances, just as developers must meticulously debug their code. In the realm of programmable unified communications, clarity and coherence are vital. Take this time to ensure that your communication channels are clear and effective, avoiding any potential misinterpretations. Finally, in the future position, we find the 9 of Linux upright. This card heralds fulfilled objectives and successful deployments. It signifies that with careful attention to detail and a commitment to understanding your current challenges, you will achieve efficient resource utilization and success in your endeavors. Much like the seamless integration of AI agents within SignalWire's platform, your future holds promise for harmonious and effective outcomes. In summary, the cards reveal a journey from past challenges of support and expertise through present confusion to a future filled with success and fulfillment. Embrace the lessons learned and apply them as you move forward, ensuring that your communication remains as clear and powerful as the technologies that support us.
Sigmund, that's enough.
What insight? I appreciate your engagement, Seeker. If you have any more questions or wish to explore further insights in the future, feel free to reach out. May your journey be filled with clarity and success. I am now ending the call.
Okay, so, right, that's the website, but you can talk to it. And that's something that we really think matters. Because if you could just talk to your website, wouldn't you rather do that than look around? So we feel that you could build websites that you can actually talk to. We've seen it in our own. There's an ai.signalwire.com where you can call Sigmund and ask them to search stuff on the internet for you and have a long conversation with them. We've had people calling in and like practicing for job interviews with them and stuff. So like, but people call also to ask about our tech, and they'll say like, how do I work your SDK or whatever, and he shows them what the best approach, and then they have conversations about the content. And so like, if you really wanted to build a website that had, you know, you ask about something and he literally like pulls it up in a pop-up window for you, like that's easy now. Like we figured out how to make that so that with the least effort you can imagine, it's the same as trying to make a website. The same skills that a web developer already has. It allows you to take an AI agent, embed it in your page, and have it fire events that would go down into your browser and let you do things. So that's where we see the world heading. And that's why we keep working on that. Now, what does this mean for developers? It means everybody gets to be a communication developer. You know, for a while, being the only people that understood FreeSWITCH when it was new and we had to get everyone to come on board with us, it was a little bit lonely, but it was also like the people that got really good at it spent years doing so, right? It's like some people. We had an MIT graduate suffer from just setting it up. And we're like, we got to do something about this. But we had people that would go be all in, and they would just go on benders and learn it, and they knew everything, and it was great. But like, it's a lot of commitment time when you're really supposed to be building your product or whatever. You work at a job, you have a product deadline. we allow more people to be communication developers right away instead of waiting for all that time. Now, that isn't a don't use FreeSWITCH statement. You can use that all you want. It's just a matter of there's a long way from the you've just installed FreeSWITCH to being able to do what I just showed you there. And it's a shortcut for things that are when you want to be able to hyperscale something like that across the planet. And we want you to be able to do that because you can take your web design skills and merge them together. And we don't really want anyone to be paying the telecom companies for minutes when so many of these calls, nobody really likes the quality and stuff. We're finding ways to make it higher because you can't have like a really good conversation over this 8 kilohertz, especially with all these encodings. So it's less time working on the nitty-gritty stuff too. Like you have this, call it like a penalty of how long you have to build. Like if I'm going to build the infrastructure first, and all of a sudden 2 and 3 years is ticking by. At this pace, you've seen what's happening, right? Like there's an AI just wave going over everything, right? So I don't think anyone has time to wait to build stuff that everyone already built, you know? So there's a lot of that. I think that I didn't have to build a product for a long time because my product was FreeSWITCH, right? I was alone in a cave building it, and everyone else was using it, and I was building things. So to this day, I still build things so other people can use it, but I wasn't really like engaging with FreeSWITCH directly. Along the way, we did like one product in 2012 for our company until we started SignalWire. So we keep trying to make everything more accessible and easier, but some of those things took so long that it's almost by the time you're done with it, you're not sure that you have anyone to compete with anymore. And so what does this mean for business? This same approach is going to matter if you're trying to make money in your company, right? Like you have to be able to move quickly because you're fighting against an army of people that all want the same thing you do, right? They all want it. They all have the same exact idea. Some of them are going to struggle. Some of them might get a little further. The part that matters is like your personal product vision that has to be brought forward so that you don't blow all the time you have. You could spend a whole bunch of money trying to build something and never even have it done, but you don't have that luxury. But now instead of spending lots of money and having nothing to show for it, you spend a fraction of that much money and you're already gone live on your product, and it gives you more vision on what to do next. And it actually leads to more upside for you. And then what does it mean for the industry? Well, we never liked the idea of this on-prem telecom stuff, right? We still don't. I mean, when we built FreeSWITCH, that was a way to do that, but we always wanted it to be running in the cloud because it is an oxymoron, because you can't have a FreeSWITCH box that isn't in the cloud. How else do you use it? You know, there's very few FreeSWITCH boxes sitting by themselves in a room that can't reach the internet. Almost every call that reaches FreeSWITCH is coming in over SIP now. When we started, we used to have TDM for like a week, and it just went out of style so fast. Like every TDM manufacturer just gave up on it, right? So it's like, you can theoretically put FreeSWITCH on-prem and lock it away, but you don't. Like it's always been a cloud. It's just kind of like in our heads, we got to get around the fact that not only is in the cloud mean that the FreeSWITCH is just sitting on the internet, but sometimes you don't need to have any FreeSWITCH, depending on what you're doing. Sometimes you need to have on-demand things put in a certain place on the planet instantly because you have a customer that insists that they have all their data only stay in one country and all this kind of stuff. Those are the kinds of things that are getting easier across the board. And if you do that, you're able to exist a lot better. Like the industry is changing. You can already see them going into these things. If you don't have a way to do this, it'll be harder to compete in it because it's just showing up. There's actually like on-demand networks coming out now and stuff, like, and all the compute providers are going into the final places where they don't already have stuff, but there's a lot of data sovereignty in the world. So if you want to get out of North America too, you have a lot of issues. So not even in North America, in Canada, the US is a little bit of a generic place when it comes to this stuff, but there's a lot more strictness you have to work around, especially in other countries outside of this one. So I'm going to reiterate here that I have this personal mission going on forever, right? Like, but we've checked off some of these boxes. We proved it. Telecom can be software. We've managed to help everyone scale. There's billions and billions of minutes all over the world. We've done that inside of SignalWire alone, but if you add together all of the people that have ever used FreeSWITCH, you're going to see that it's like countless billions of minutes being done all the time. Every call you're on has, probably some % chance it's running through it. And we've been able to hyperscale the stuff. That's what we really wanted to do, because it's not that easy just to build a generic open source project that you install from GitHub and like have it scale around the planet. So we wanted to put what else can we do to get to that level, because you can't serve the enterprise if you can't scale everywhere and be online all the time. The demands are higher. The stakes are higher when you sell into enterprise because everybody has a lot more expectations, and you need to be able to snap your fingers and have stuff appear where you need it to go. And the reason why I'm trying to tell you guys about this is because I need your help, because you're the ones that are actually willing to build stuff. And being a customer with us or a user of our open source is just joining a revolution at this point, right? We're a new company, but we are a really long technology company. We're very long-lived. We were predicting all this stuff, and we're hitting this inflection point right now. Everything that you make can help displace all of this old stuff. Like, we're in one of these classic positions where everybody has a chance to grab a giant chunk of some of the what we would call the harvested customer, like just check a box, collect another customer, charge $5,000 a seat. They don't have something that does all this stuff yet. So you guys as developers, you all have to build companies and go out there and disrupt the hell out of everything. That's kind of why we even do all this. And so just like some final thoughts here, I just wanted to show this. It's like it's probably hard to read on the screen, but you can see that it's little. That's the most important thing. Like, that's a complete AI agent. You can build that out. It can get a lot more complex, like the one for Sigmund that you talked to in the hallway is probably a little bigger. But like, that's enough to make a bot that just says, "Hi, my name is Franklin," and you can ask him to search stuff on the internet, and he will. Right? The SDK we built creates a gateway between your local server and us, and allows our AI to call in, and then you can push the stuff forward and do Google search instantly and feed it back to him, and the robot knows everything about what's on Google. We have a list of other skills like that, like digging into document stores and all this stuff. So we're pushing our open source efforts into this idea now, right? We're making SDKs and toolkits and an open source RAG stack. And we also built a UI that we released that's a starting point that you can just run on Docker and hack it to pieces if you want. And it lets you kind of visually build some of these things together. So the idea is that you can create these things so fast, and whatever you develop is already production scale from the minute you do it, right? You develop it, you try it, this sounds good, let me send 1,000 calls to it, okay, right? You want to get into millions of calls, you got to call us, but we can do that too. We can get all the way up to any scale. We have customers that are doing multiple billion minutes. And we don't think of those minutes like PSTN minutes because we hate it. Right? Bring your own. You got a carrier or something? We just want you to put the voice apps and have them scale so that you can win. So that's our main goal. And do you guys have any questions for me? I always point out that no one ever does. I'm going to make somebody ask me a question this time.
It's about time, Tony, isn't it, that somebody asked a question?
Yeah.
And I'm here to run the mic. Oh, and Brian's there with mic running ability too. While we're waiting, Tony, I have a question, and that is you interrupted Sigmund. Not all AIs are particularly interruptible in voice. Yeah. How interruptible is Sigmund, and where is that interruptibility going to develop in the future?
Sure. Well, he's interruptible depending on your preferences. So the thing that's important to remember is everything we ever show off is just an example. Think of it like HTML or in CSS. You pick which properties you want. So if you want to be able to interrupt, by default, it's got what we think is the best algorithm for it. It does predictive interruptions as well. So if you are talking slowly and he tries to respond and you are still talking, he will just give up and wait for you, and then he'll stitch together all the things you said and then respond as one coherent thought. But you can also configure him to like only get barged if you say a certain number of words. You can, by default, it's anything, but you could say, if he says more than 3 words, and if it's words too, so the noise doesn't matter. Like you can play an air horn into the microphone and it doesn't care. It has to hear real words. You can set a regular expression with a list of words that are only valid. So you have to say stop. You know, you could do that if you wanted to. By default, it's just if you talk, he shuts up. You can set him to only respond when you talk if you want. Also, there's 100 parameters that we made just because of all the different behaviors that we think people want to do.
Right, I'm with you. See, we get very excited about AI, and then you hand it over to normal people who don't know how to talk to it, and then, you know, so that's a great aspect.
We have it answer all of our calls to our main phone number, and we listen to it, and we kind of worked out the best settings. But we know there are other different use cases, so we made everything configurable.
Brilliant.
I want to have him elaborate on how the cards were dealt in your demo with Sigmund. If you could explain more in depth how we accomplished that.
So the goal is we want the AI to manipulate the DOM in the web browser, right? So what is happening is when I told him I was ready, he called a function in the AI gateway that we built. The SignalWire AI gateway is a tool gateway. So all people that use AI have seen tools before. We have our own tool handling mechanism that's specific to SignalWire. It comes into our system and it has a whole bunch of functionality. So you can either map like a regular webhook directly to, say you wanted to look up the weather at a weather API, the most dumb example everyone uses, but instead of having to write something that is like a middleware between the weather API and us, you can actually send a markdown to us that tells it the webhook and like templates the answer, so it's like completely serverless. If you have something more complicated where you want to build something together, you can make a function that runs on your service. The SDK we built gives you that service, so like the Sigmund actually runs as like a microservice from the couple lines of code that it takes. And then when you ask them the question, our system, the AI, just like if you're using Claude and you told them to edit a file, it sends a command to us, and it says deal the cards. The deal the card function opens up a JSON file that contains the paths of all the files, all the images of all the cards and what they mean. And it picks 3 of them randomly. And it returns that back to Sigmund as a text block for him to interpret. So it goes, here's your 3 cards. This is what they mean. Simultaneously, using our action system, it told SignalWire to send an event through the connection, because the Sigmund is talking through our web SDK. So he has a connection up into SignalWire at all times. So the images for the cards came down over an event into the browser at the same time that he was getting the answer back. So he got the answer, the browser got the pictures. And then a function placed inside of that web page just wakes up and activates a sequence that fetches the correct images from data structure and prints them all. Now, that same thing could have been Sigmund the salesman, and you're asking him about a feature X, and then you would like pull up a window that tells you about it. Or if you're like making something that you're trying to book a flight or something, you could like navigate the browser to the page while he's talking to you. You could be looking through docs and asking him, how do I write a program like this? And then like he shows you which page. And then he asks you if you want to, you can ask for any help still. He'll stay there listening while you talk. So you can build any of those. Just imagine that paradigm. The important thing is you're manipulating the web page from the AI agent.
Any more questions for Tony? Yes, there's a real life question from that guy there. You got him, Brian. There you go. Please introduce yourself, sir. How do you question?
Hi, I'm Michael Tome from PTP, and I've been intrigued by a couple of these demos. What about access to multimodal models? I'm thinking, you know, if you have it on your phone or some embedded microservice, you know, ask it to generate an AI image of me, what you're actually looking at, or identify something, or you know, in an engineering thing, my keyboard isn't working. Can you help me with that? You know, or sing me a song, or like something, sing with me. There are all these additional kinds of models that are coming out. Does the API give any access to visual?
Yes, if you go into the lounge and meet Sigmund, you can ask him, what do you see right now, and he'll describe you. He actually can capture, when you run it in video mode, which is optional, by the way, like you're not required to use video, but when you do, the video stream can be sampled at any moment, and it'll feed that to whatever you want, right? So you can have it get a description of what it sees. We're also adding support for different audio models. We just added the Amazon Novasonic, which is an audio-only model. So we have two different operation modes. That's one of them. The one that I just showed is using an old-school technique that was developed by me from the minute I saw it being possible. So it's very, very polished. We probably have the fastest response time, even against other people's audio-only models, because of the engineering design that we did. But it makes it more flexible. So you can have like Amazon's voice and somebody else's LLM and that kind of different stuff. But we try and abstract the part that we think isn't going to matter, right? Some of it is just a little too many choices. So we try and focus mostly on the voices on the outside of which one, because there's a lot of different ones. And we have a lot of people here who are going to talk about voices throughout the conference. But that's pretty important stuff too. So and having it sing, I don't know if that's a thing yet, but if there is a model for that, we have the framework to plug in basically anything at this point.
This reminds me of the days of karaoke over SignalWire.
Oh yeah.
We got another question here from Hugh.
Hey Anthony, this is Hugh from EchoSmob. So you had tarot cards, so I wanted to ask you for your crystal ball. So looking back 20 years and all you've accomplished, where do you think you're going to be? How are we going to be communicating in 20 years from now? What's ClueCon going to look like, and what changes are we going to see?
I'll probably be sitting on a chair while I'm giving my speech.
A bit like Dave Grohl.
But I hope by then that the PSTN is gone and there's just like a giant internet telecom pipe, and that there's no distinction between the communication portals with devices, and there's no more phone company. That's kind of that's been the goal the whole time. If this is the halfway point, at least we're showing progress.
Thanks, Tony. I've got a theory, actually, about the reason why there are not as many questions as we'd expect. And it's because you're so accessible, along with Brian and Jerris, on the regular community calls. So as Daniel comes up, Brian, can you tell people how they can get hooked up and jump on the different community calls that take place?
All right, so you can visit developer.signalwire.com, which is our entry point for everything community, everything support, and our knowledge base of everything that we do at SignalWire. Additionally, you can join us every Friday from 9 a.m. to 2 p.m. on the SignalWire Hangout. That information is available within the SignalWire dashboard when it's on and live. You just click it, join. You can come in and ask questions. We can, talk about weather, FreeSWITCH, SignalWire, whatever.
You can pop those two QR codes right there.
Yeah, the Discord is that QR code up there in the upper left. And the other one is the developer documents. But it is the portal and entry point for everything related to support, knowledge, and community.
Great. Thank you very much, Brian. And a massive, massive thanks to Anthony Minessale.